next topic is stabilizing effects in the molecule. These are basically four types. Uh, okay, on effect I have not given here because this effect is only required at the time of reaction. Okay, so stabilizing effects in the molecule. These are basically inductive effect, resonance effect, hyperconjugative effect, and steric inhibition of resonance. So first one is inductive effect. Here we know that all the molecules have different electronegativity, means this Cl is much more electronegative than this CH3.
Yes,
So
sir.
this bond,
Yes, sir.
in this bond, the electron which is shared between these two bonds will be towards this Cl atom,
Yes, sir.
and
Yes, sir.
for this carbon, if we go for this carbon, so this effect is actually called as minus I effect of Cl. So every halogen possesses this minus I effect. So every halogen possesses this minus I effect. So in this molecule, there is, this is on tertiary carbon, and with this on Cl atom is attached, and another three CH3 molecules are attached. These CH3 groups or alkyl type of groups, these groups basically gives is a plus I effect, means it pushes the electrons toward this bond. Okay, but this plus I effect is very less compared to other effects. We are just, in this class, we are just going to um, a basic description of these effects which will be required for your exam, but we will not go much more detailed in this topic. It will be done after your mid-sem. Okay, so the simple picture of inductive effect can be drawn like this. Here Cl is more electronegative atom. So this carbon center will be much more positive, and this Cl will be much more negative.
Yes, sir.
Okay, so this is the basically inductive effect. So inductive effect, it operates through this bond is which bond is this one? Is this sigma or pi bond? This bond is sigma bond. So
Yes, sir.
inductive effect basically operates through this sigma bond. Okay. So our next effect is resonance effect. So for resonance effect, okay, so I have shown the groups which shows minus I effect, means this NO2, fluorine, COOH, Cl, and all other halogens, they gives minus I effect, and this tertiary methyl group and other substituted methyl group gives plus I effect. Okay, so I am coming to the electromagnetic effect in your next class, because this effect requires when we are adding any substituent or any reaction is taking place, then this effect is important. It is similar to a resonance effect. You can say this pi electron has been delocalized by means of any reaction. Okay, so for resonance effect, this can you say which type of species these two? These are plus charge given, so these are carbocations.
Yes, sir. Carbocations.
Okay, so both are here. How many hydrogens is are present on the carbon atom? In this carbon
Sir,
atom, how
three.
many hydrogens?
Three, sir.
No, not three. One hydrogen is present. You check. One plus charge is there, and it is bonded with two carbon. Say if it is not bonded with any carbon, then there will be two hydrogens. If you just replace one CH bond by taking the electron pair, this bond will be removed
Yes, sir.
and one plus charge will come here.
Yes, sir.
So there it is. So this carbon has one hydrogen. So it is, you can say, 2 degree or isobutyl type of hydrogen. So how this carbocation can be stabilized? Here you can see there are three different CH groups. So these methyl groups, we have said previously, these methyl groups have plus I effect. So methyl group
Yes,
can
sir.
give electron to stabilize this center.
Yes, sir.
This methyl group has plus I effect, so it will push its electron towards this positive charge charge place. Similar to this case also, but here along with this CH3, one double bond is here. So double bond means it is pi bond.
Yes.
Yes, sir.
Okay, and when a carbocation forms, it gives a p orbital, vacant p orbital. So here pi bond is also formed by the overlap of these p orbitals. Okay, so this allyl carbocation, it is called allyl carbocation. It can be stabilized by delocalization of this pi bond.
Sir, repeat
Okay,
please.
so
Pi bond.
okay, so when a carbocation forms, there is a vacant p orbital will form, and in this pi bonds are formed basically overlap of two p orbitals, whichever we have learned previously. These pi bonds are formed by the overlap of p orbitals. So this bond can break and another bond can form here by the delocalization of these pi bonds.
Yes, sir.
So if it reacts, then this can be written like this. This form can be written like this. Means this pi bond is came in this position. So this positive charge will go and this positive charge will come at this position.
Yes, sir.
Yes, sir.
Okay.
So that is the resonance effect.
Yes, yes. It is actually the resonance effect. So
Yes.
you have heard about the aromaticity previously. Okay.
Yes, sir.
Okay. So in aromaticity, there is also this type of effect. The similar type of effect is also there.
Yes, sir.
Yes, sir.
Okay. So okay. So these two forms can be
Sir, means
called as
for these
its.
vacant p. Sir, means for these vacant p orbitals, this double bond is 50.
Tell.
So means the for the vacant p orbitals, the
Sir,
sir, the sound is not coming, sir.
Is it audible now?
Yes, sir.
Yes,
Okay,
Yes,
sir.
sir.
okay. Just a minute. Okay, so is it okay now?
Yes,
Hello?
sir.
yes, sir.
Okay, okay.
Yes, sir. Now sound is okay.
Sir, again, not sound. Sound is not coming, sir.
Is it audible now?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
Some
Yes,
network
sir.
problem is there. Okay, just a minute. Okay, so this pi bond can delocalize in this way. Is it
Sir, would you
audible?
please tell it again, sir?
Okay, so this allyl. Okay, for this carbon, there is a pi bond, and this pi bond can delocalize to this p orbital to form this type of bond, this pi bond, and this positive charge will come there. So these are two canonical forms formed by this resonance. Okay, so the structure of benzene can be written in this way, in these two forms.
Yes, sir.
Okay,
Yes,
just
sir.
if we 2, it is 3, it is 4, it is 5, it is 6. So in between these two forms, in this form, this green colored form, and this
Sir, would
violet
you please
colored,
repeat why the double bond is shifting?
why the double bond
Is
is formed.
shifting.
Yes, it is basically delocalization of this pi bonds. Means this electron cloud is shifting from this position. This electron cloud, which is present here, it is shifting from its position to this position. Okay,
Okay, sir.
since uh, these p orbitals are conjugated, means one after on after this p orbital there is another p orbital, then another p orbital. So this electron cloud can delocalize between these p orbitals. Okay.
Okay, sir.
Similarly, in case of benzene, you can see in this form there is bond between 1 and 6, 5 and 4, 2 and 3. But in the second form, there is bond between 1 and 2, 3 and 4, and 5 and 6. So it means that these pi orbitals has been delocalized in this way, in this way.
Yes, sir.
Okay, to form this. Okay, so this is the resonance effect, means, and among all the effects, this resonance effect plays the major role to stabilize any substance, means carbocation, carboanion, or free radical. This resonance effect will be the much more prominent effect in all the cases. And if resonance effect gives aromaticity, then it is the most prominent effect, most prominent stabilizing effect in the stabilization of any substituent. Okay, so this is the
Okay, sir.
basically resonance effect. Okay, so there is a small note is given on resonance effect. Just what is resonance effect? In this mid-sem exam, you will be asked what is the resonance effect, or what will be the hyperconjugative effect, or what will be the inductive effect. So this is the resonance effect. Okay, so this resonance effect is basically formed by this through these pi bonds, means this pi bond is delocalized in this manner. So
Yes, sir.
next effect is hyperconjugative effect. In this hyperconjugative effect, see there is a carbocation, this is carbocation similar to the previous, but in place of In the previous case, there is a pi bond behind this carbocation, but in this case, the electron of CH hydrogen basically delocalizes to form this type of canonical form. Means this sigma electron has been donated to its vacant p orbital in this way. Okay, so this
Sir, please repeat
delocalization,
hyperconjugative effect.
in hyperconjugation, this CH bond electron of this CH bond has been delocalized to p orbital of an carbocation to form this type of canonical structure. Okay, so in definition, if you go by definition, hyperconjugation is also a type of resonance where electrons are delocalized through the overlap of a sigma CH bond on a saturated carbon atom with either vacant p orbital or half filled p orbital or vacant pi orbital of the unsaturation system attached with the solid saturated carbon. Unsaturation means there is either pi bond or vacant p orbital or any half filled p orbital. Okay, unsaturation means this double bond or this type of carbocation. Okay, this means it is unsaturated.
Okay, sir.
Okay, so hyperconjugation is on kind of resonance where this sigma CH bond of a saturated carbon just overlaps with p orbital to form a canonical structure and thus stabilizes this carbocation. Okay, so I am just going back. Can you say if there is any hyperconjugative effect in this carbocation?
Yes, sir.
So this is unsaturated carbocation. I am just omitting this portion, this allyl
Yes, sir.
portion. If we omit,
That
then
is the
this
bond replace
carbocation,
the
Yes, sir.
yes,
yeah.
so for hyperconjugation, there will be three CH bonds.
Yes, sir.
Three CH bond can participate in the hyperconjugation. Okay, so this carbocation will be stabilized by three CH bonds. Hyperconjugative effect of three CH bonds means these sigma bonds will participate.
And sir, the bonds need to be pi bonds.
Which bond?
So for hyperconjugation, the bonds need to be pi bonds.
No, no, no. Bond needed not to be pi bond. Uh, this hyperconjugation can be possible if uh, beside a CH bond there is a carbocation or either a pi bond. Then this electron from this sigma bond can be delocalized to the pi bond as shown
Okay, sir.
here. Okay, it can be either this carbocation or it can be this type of pi bond. Then this CH bond electron can be donated over there. Okay,
Yes,
so this can be another kind of hyperconjugation. Okay, so depending on the nature of hyperconjugation, the stability of a carbocation can be decided. So this carbon with this carbon, there is one hydrogen, so it is 2 degree carbon. It is 3 degree 3 degree carbocation.
better. Yes, sir.
Okay, there is, I think it is given. Okay, so I'm just writing here. Okay, just I'm writing here. If this is a carbocation and uh, say this is a carbocation and this is also a carbocation. So it is 1 degree, it is 2 degree and it is 3 degree. Okay, so for 3 degree, how many hydrogens are there for hyperconjugation? In every carbon there is 3 hydrogen. Here is also 3
Yes, sir.
hydrogen and here is also
Yes,
3
sir.
hydrogen. So it will be stabilized by hyperconjugative effect of 9 hydrogens.
Yes, sir.
This tertiary one means 3 degree carbocation. This 1 D will be stabilized by means of 3 and this one will be stabilized by means of 6 hyperconjugative effect of 6 CH bonds.
Sir, please repeat, sir.
Okay, so the stability order will be okay. So this one is tertiary or 3 degree carbocation. This one,
Yes, sir.
this carbocation. So this carbocation has 3 methyl group attached along with this. So this carbocation can be stabilized by hyperconjugative effect of these 3 CH3 groups. So in hyperconjugation, these CH bonds play a major role. So there is 9 CH bonds in these carbocations. In
Yes,
this
sir.
first carbocation, there is 9 CH bonds. So this carbocation will be stabilized by the effect of 9 CH bonds. And if we go to the secondary, is 2 degree, there is 6 CH bonds.
Yes, sir.
Yes, sir.
So it will be stabilized by hyperconjugation of 6 CH bonds.
And 1
Okay.
degree,
Yes, sir.
3 CH.
And 1 degree it is 3. Okay.
3. Yes.
So this is the order will be first is 3 degree, then 2 degree,
Then 2 degree,
then
then
1
1
degree.
degree.
Okay.
Okay, sir.
So is it clear to you this hyperconjugation effect?
Yes.
Yes, sir.
Okay. So, and this hyperconjugation is also called as no bond resonance. Means in the resonance there is a pi bond in actual resonance, but here these sigma bonds play the take part in the resonance. So this is called as no bond resonance. It is also given in this note. Where I have given, yes, here it is given no bond resonance. Okay, I will share both the PPTs after the session. Okay.
Okay, sir.
Okay, so I'm removing this one. Okay, so our next effect is steric inhibition of resonance. It is actually an effect where steric. Do you have? Can anyone tell what is steric effect? Steric effect means repulsion between two groups. See here on NO2 is present and on iodine is present. So both this iodine and NO2 group will repulse in between them. Okay. And in aromaticity or in resonance, the major criteria for resonance is, see if there, say it is a cis state. for resonance. So it is conjugated pi bond. So all the 4 carbons have p orbital. So it can resonance. It can resonate. So it is the major p orbitals would be in same plane. Okay. But in this case, if the resonance, if this NO2 molecules try to resonate phenyl ring, then this NO2 molecules will must have to be in same plane with this aromatic group, means this benzene ring. Have you any doubt at this point?
Yes, sir.
Hello. Okay, so if you have any doubt, then you can ask. When the major criteria for resonance is all the p orbitals should be in same plane. So if I say I want to resonate this NO2 with this phenyl ring, then this NO2 should be in plane with this aromatic ring or this benzene ring.
Yes, sir.
Okay, but in case of steric inhibition resonance, what happens? These iodine and NO2 groups repulse in between them, and due to this repulsion, one group becomes out of plane with each other. Okay, so can you tell which bond has longer length, means C single bond C or C double bond C? Which bond
Sir,
has
C
longer
double one
length?
C.
No, longer length. I am telling
Length.
bond length.
It's a single bond longer.
Single
Yes,
bond, sir.
single bond is longer.
Sir,
So
no,
if
I heard
resonance,
straight.
okay, okay. So see if please. Okay, if NO2 resonate in this manner, then this bond will be a pi bond, and
Yes, sir.
this will be the structure if
Yes, sir.
we draw in this manner. This is oxygen and this is double bonded oxygen. Okay, so this bond will be shorter. This NO2 bond will be shorter. Okay,
Yes, sir.
so here is 3 C single bond N, and this position is para, and what this position is called? Position, it
Sir,
is
meta.
meta.
Meter.
Okay,
Yes, sir.
okay, so it can be asked which which CN bond has longer length in between these 3 CNO2, means this NO2 cannot take part in the resonance with this benzene ring due to steric inhibition resonance, but this NO2 present it at para position can take place in
Yes,
resonance.
sir. Yes, sir.
So this bond will be shorter and this bond will be longer.
Yes, sir.
Yes.
Okay, so this effect is basically steric inhibition of resonance. Means inhibition means it is basically obstruction মানে যেটাকে বাংলায় বাধা বলছে আর কি।
Yes.
ওকে,
Sir, means in the ortho position, the bond will be always longer.
no, it is not the case. If you have given,
Means, sir, if steric hindrance is
okay,
there, then always ortho position.
yes, if there is steric hindrance,
Okay, sir.
if you have given this type of things, NO2, here is also NO2, here is also NO2, so then all the C single bond ends are identical, means all can participate in conjugation of this phenyl ring.
Okay, sir.
But in this case, due to the presence of this I, I this there is a steric hindrance, so this NO2 becomes out of plane to this phenyl ring and it cannot participate in conjugation with this phenyl ring, and that is
Yes,
why
sir.
this C single bond N is longer as compared to these other bonds. Okay, so
Okay,
this
sir.
is steric inhibition resonance. So I have given basic idea of four stabilizing effects. So in Mishsen, it will be asked what are these effects, and if possible, to give an example that not much more than it will be asked in your Mishsen exam. Okay.
Okay, sir.
Okay, so there is some examples is also given uh, in steric inhibition by using this steric inhibition resonance. So this will not come in your Mishsen, but you can check with this. Okay, and at last the effect extent of the effects has been given. First, most prominent effect is aromaticity, then is resonance, then minus I, then hyperconjugation, then last one is plus I effect. Okay, so at this point
Okay,
I
sir.
am ending. Okay, so tomorrow your practical class will be from 2:30, I think.
Yes, sir.
Yes.
Okay, so at this class I will discuss about hardness of water. Previously we have done the alkalinity of water in your lab. So I will discuss about hardness of water, and it will not take much more time, and after that I will try to uh, cover some portion. uh, Most of the portions of your midsem has been covered. You can say about 95% has been covered. One thing is left, which is substitution reaction and elimination reaction. Okay, for your midsem exam most of the things are covered. I am
Okay, sir.
sending the slides after this session. If you have any doubt, then you can ask. I will repeat those things in your next
Sir, in
class.
the aromaticity part, this part is the till this part, it will be our
Okay,
syllabus.
actually, I have not told about aromaticity. I have just given the what are the stabilization effects in the molecules. Okay, uh, and how these effects can stabilize the molecules. I have not given aromaticity, and from aromaticity in your midterm exam, there should not be any question. Okay.
So means till this portion, it will be our syllabus for medicine.
Yes, most of the syllabus has been covered. One thing is left, which is substitution reaction and elimination reaction. Just I will give you some just basic idea of substitution and elimination type of reaction.
Okay,
Okay,
sir.
in your next class, if possible by tomorrow, or if you guys say by next week, then I can tell it by next week. Okay,
Okay, sir.
meanwhile, just summarize the questions whichever I have told for every modules. Somebody have to send me some questions by writing the answers. I have sent the answers for all your acid base questions. Okay, so kindly focus on those questions for your mid-sem exam for every module and try to summarize all the questions whichever I have given previously. And if you have any question regarding these modules and questions whichever I have given, then you can ask in your later classes or in your WhatsApp group also.
Okay, sir.
Okay. So I am ending at this point. In this class, have you? Is there any issue or any doubt in this class?
No, sir.
Okay, so I am ending at this point.
Okay, sir. Thank you,
Sir,
sir.
attendance.
Okay. Attendance
Sir,
एक sheet
Pranay
कर
has
दो.
shared, sir, already.
Oh, you have
Okay, sir.
shared. Okay, okay,
Sir, no,
okay,
not me, sir. Pranay, our seer has already shared.
okay, 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 okay. I'll check.
Okay, sir. Thank you, sir.
Okay, thank you.